Question 7 of this exercise says an elevator descends into a mine shaft at the rate of 6 meters per minute. If the descent starts from 10 meters above the ground level, how long will it take to reach minus 350 meters? So we are given the initial level of the elevator, which is 10 meters above the ground, and the final level of the elevator, which is minus 350 meters or 350 meters below the ground. We are also told that the elevator descends at the rate of 6 meters per minute. Using all this information, we have to find the time of descent. So let's start this problem. Let's solve this problem step by step using the concept of integers. Here's a figure that I have drawn which will help you visualize the situation better. So this green thing that you see here, this is the elevator. This is initially 10 meters above the ground, and it has to go all the way to 350 meters below ground. And this level here is the ground level. Okay. So this is how you can visualize the given situation. Now, according to the problem statement, what we will do is any distance above the ground, we will represent it using a positive integer, any position above the ground, and any position below the ground using a negative integer. So because the elevator is initially 10 meters above the ground, we can say that its initial level is plus 10 meters. So let's write this information. So the initial level of the elevator is plus 10 meters. Okay, and this assumes basically that the ground level is the zero level. So the initial level of the elevator is plus 10 meters. What is the final level of the elevator? So the final level of the elevator is 350 meters below the ground, which we can write as minus 350 meters. So what will be the change in level? So from these two numbers, we can say that the change in the elevator's level from initial to final will be the final level, which is minus 350 meters, minus the initial level, which is 10 meters. So we are subtracting from the final level minus 350 meters, we are subtracting the initial level, which is 10 meters. So this will be equal to minus 360 meters. So the change in level is minus 360 meters, which basically means that the elevator is going 360 meters in the downward direction. Now, what is the rate of change? What is the rate at which the level changes? So the rate of change in the elevator's level is, we are given this 6 meters per minute downward. So the rate of change, we can write this as minus 6 meters per minute because the elevator is going down. And from here, we can say that the time of descent, the time which the elevator takes to go from plus 10 meters to minus 350 meters, this will be equal to the change, the total change by the rate of change, right? So the total change is minus 360 meters. We calculated this, and the rate of change is minus 6 meters per minute. So this is how we can calculate the time. And how much is this quotient? So both dividend and divisor are negative, so the quotient will be positive, and 360 by 6 is simply equal to 60. And what will be the unit? So the unit will be minutes. So we will get this quotient as 60 minutes, which we can write as 1 hour. So the time of descent is 1 hour, and 1 hour therefore is the answer for question number 7.
To learn more about how QMath can help you crack school and board exams, explore QMath Leap, a live online classroom program run by highly experienced and committed teachers.